All right, everybody, we are going to be studying systems of linear equations today. We are graphing and talking about and analyzing two linear equations at the same time. You know what? I'm going to change my mind. Recording. Stop recording. All right, everybody. Today we are going to solve systems of linear equations. Systems of linear equations means we're going to have two lines and we're going to be solving them at the same time. All right, let's give it a try. Please make sure you have your book out. We're on page 177. You need to be taking notes. I'm not going to lie, this is tricky stuff. This is some of the hardest stuff we're going to do all year. Let's get through this. Let's work hard, ask for help, don't fall behind, and then I promise we'll move to something easier and more fun. Okay, so Chip decided to upgrade the landscaping in his yard. He bought a 10-gallon mesquite tree and a 50-gallon desert willow and planted them. After 1 year, he was shocked at the growth of both trees, so he measured their heights. The mesquite tree was 5 feet tall and the desert willow was 8 feet tall. The next year, he measured again and found the mesquite tree was 6 feet 6 inches tall and the desert willow was 8 feet 8 inches tall. So the first thing they'd like us to do is list all the numerical information associated with each tree. All right, let's see what we got here. So let's start with the mesquite tree. They say it's a 10-gallon mesquite tree. It says the mesquite tree was 5 feet tall after the first year, and that it was 6 feet 6 inches tall after the second year. So that tells us everything numerical about the mesquite tree. Let's check the desert willow. Maybe we should use green. It's a willow. We'll use green. All right. So he bought a 50-gallon desert willow. So that's numerical. I guess I should be highlighting the 1 year, but the 1 year is for both. I'm going to highlight it in both colors. So 1 year applies to both the mesquite tree and the willow tree. The mesquite was 5 feet tall. The willow, whoops, wrong color. the willow was 8 feet tall after that 1 year. The next year, that isn't a number, but it would be year 2, right? So I'm going to highlight that in both colors as well. Here's the thing about systems, is that you can have things that apply to both situations. Okay, so the next year, the mesquite was 6 feet 6 inches and the willow was 8 feet 8 inches tall. So this is a lot of information and we don't actually need all of it. Can you figure out what information we do not need if we're comparing the length of time and the height of the tree? Well, yeah, we don't need the gallons. They measure trees when you buy them by the size of the container the dirt is in instead of the size of the tree. So it's 10 gallons of dirt that the mesquite is growing in and 10 gallons of dirt that the willow is growing in. That's not going to help us figure out how tall the trees are as the years go by. So those we're not going to use, but all this other information we are going to use. Let's move on. Hopefully you put this in your book because I am wiping it out. Moving on. Okay, so now it says if the trees grew at a constant rate for the first 2 years, how tall were they at the end, or how tall were they when Chip planted them? All right, the key information here is grew at a constant rate. So that's a huge assumption that we're making, that these trees are always going to grow the same amount every year. So let's put in the information that we know. So we know the years. So for the mesquite tree, we have 1 year and 2 years. I'm going to skip a line and leave a space for 0 because they're asking us how tall were they when Chip planted them. That would be year 0, right? So in this example, X is years. So let's put our information in. After 1 year, the mesquite tree was 5 feet tall. We do not want to use feet and inches. That would be so obnoxious. So let's change 5 feet into just inches by multiplying it times 12 inches per foot, right? So we would get 60 inches. All right, so in the first year, after the first year, when he measured it for the first time, that tree was 60 inches tall. All right, and then the next year, the mesquite tree was 6 feet 6 inches. So I'm going to take 6 feet and I'm going to multiply it by 12 inches per foot for 6 feet. And then I'm going to add the 6 inches, right? 6 feet, 6 inches. I'm going to add the 6 inches. And altogether, I'm going to get 78 inches. So 78 inches for the second year. Everybody with me? So they're saying a constant rate. Let's figure out what that rate is. So when the year increases by 1, the height of the tree increased by 18 inches. Does everybody see that? And if it is a constant rate, that means it's always going to grow 18 inches every year. So if it goes from 2 years to 3 years, another increase of 1 year, it should increase 18 inches and be 96. So we can check. At the end of next year, we can see if it's 96 and then we'll know whether it was growing at a constant rate. But I can use this constant rate to go back in time and figure out how tall it was when he planted it, right? I need a number that I would add 18 to and get me to 60. Or I could think of 60 minus 18, and that's going to be 42 inches. So this is inches. Okay, do it for the willow tree, please. See if you can fill it in for the willow tree. All right, so same number of years. If you convert the height of the willow tree into pure inches, for the first one, you should have gotten 96 inches. For the second one, you should have gotten 104. And we can see hopefully that that constant rate is 8. So 8 inches per year is what we are assuming for the willow tree, which means it would have been 88 inches when he bought it. And it's going to be 112 inches in the next year. All right, please make sure you have this in your book. These tables aren't in your book. Should have told you that earlier. You have to draw them yourself. Okay, so now they're asking, page 177, use the table below to help explain how the height of the mesquite tree compares to the height of the willow tree over time. So this is something we do for systems of equations, where we put information for two different linear relationships into one table. Because do you see how the x column of the table is the same for both of them? So we're going to use one column for the x. So this is our x, and it is years. And then we're going to have two columns for the y, a y for the mesquite tree and a y for the willow tree. We'll have to keep that straight. So for the mesquite tree, we had 42, we had 60, we had 78. I'm going to let you go ahead and fill out the rest of this table. Whoops, that's not what was supposed to happen. There it is. All right, so hopefully you filled it out and it looks like this. So here are all the numbers, but they ask us to explain how the heights compare over time. So let's look early. We're going to look at early in the life of these two trees. Early in the life of the trees, we can see that the, let's use blue, that the willow tree is taller. So we can say at the start, the willow tree is taller, right? That's something we can tell. And then look down here at the bottom. Let's look at the bottom of it now. So after 7 years of constant growth, the mesquite tree is only, the mesquite tree is 168 inches and the willow tree is 144. So at the end of 7 years, the mesquite is now the taller tree. And that must mean that the mesquite tree is growing faster, right? That's how that happens. But we actually know how fast it's growing. Remember, we said this had a constant rate of 18. So that's a growth rate of 18 inches per year. And we said this one had a constant rate of change of 8. So yeah, we knew that the mesquite tree is growing faster. So it makes sense at some point, the mesquite tree is going to become taller than the willow tree. So our table can tell us that. All right. So now we're going to write some equations. The book would like you to use M for the height of the mesquite tree and W for the height of the willow tree. But I know from past experience that leads to pain and suffering. We do not want to do that. Don't use different variables to represent the same thing. So we are going to use H for the height. H for the height in both of them because they're both representing the same value, just like we're going to use T for the number of years for both equations. So let's start with our mesquite tree. So this is our mesquite tree equation. And our equation, because of that constant rate, we know the equation is going to be y equals mx plus b. So we decided to use H for the height in inches. Okay, so we're going to replace all of these letters. We're going to replace y, the output, with H because the thing that is changing is the height. We are going to replace m with our constant rate. And for the mesquite tree, the constant rate was 18. We're going to replace x with t because our input, the thing that's passing, that's causing the height to change, is time. As time is passing, the height is increasing. And then B is our starting value. So we're just going to go to year 0 for the mesquite tree in our table here and say that that has to be 42 years. So this is our mesquite tree equation right here. Let's make it yellow. Mesquite tree equation. All right, let's write one for the willow tree. For the desert willow, what is the equation going to be? Well, again, it's going to be y equals mx plus b. Again, the height, we're going to use h. The rate is different. So m is going to be different for this one. It's going to be 8, right? An increase of 8 inches per year. We're multiplying that times t because that's the number of years. Plus, it has a different starting value. So let's look. In year 0, it was 88 inches tall. So plus 88. Okay, let's make that one green. Those are our two equations. It's a system of linear equations. So we have two equations. In the two equations, the variables are going to represent the same thing. So even though we're talking about different trees, in both of these equations, t is standing for time in years, and h is standing for height in inches. Is it possible to use the equations you wrote to describe the growth of the two trees to predict the height of the trees at 1.5 years? I hope that you said yes. We did this on the last quiz, didn't we? The quiz you just took. So let's start with the mesquite. Make it yellow. So for the mesquite tree, I can predict how tall the tree was at 1.5 years. I am just going to substitute 1.5 for years, right? So t is equal to years, and h is equal to height in inches. They're giving me years, so I'm going to substitute it for t, and I'm going to leave h alone because that's the thing I don't know. They asked, how tall will it be? So h is the unknown. I'm going to replace t with 1.5 plus 42. And all my numbers are on one side, my variables on the other, so I don't even have to solve this. I can just simplify. So 18 times 1.5 is 27. Hello, where'd my pen go? There it is. Interesting. So 27 plus 42 equals to 69. So h is equal to 69 years. We can do the same thing for the willow tree. Let's bring our willow tree equation in here. So we got h is equal to 8t plus 88. Let's color it green. So that's our green equation right there. Okay, and we're going to do exactly the same thing. We're going to keep h for the height. That's the thing we don't know. We're going to place t with 1.5 because we want to know how tall it is after 1.5 years plus 88. So h is going to be equal to 8 times 1.5 is 12 plus 88. Oh, a nice 20. No, that's not right. 88 plus 12 is 100. That's a beautiful number. So round. So h is equal to 100. Why did I put years over there? Height is in inches. Inches. So this should not be years. Let's get an eraser. Oops. There we go. It should be in inches. Alrighty. Nope. Nope. Inches. So 69 inches and 100 inches. That is our prediction. All right. let's move on. Graph the equations on the grid below. Use the graphs to determine what year the mesquite tree will reach the height as the willow. So this is what we are doing when we are solving a system of equations, is we're trying to figure out when both equations have the same value, the same x and the same y, or in our case, the same h and the same t. So we had, for the mesquite tree, we had h equals 18, t plus 42. And for the willow, we had h equals 8t plus 88. On the horizontal axis, our input, this is time in years. And for our vertical, our y, this is going to be height in inches. All right, sloppy, but okay. So now we're going to graph our points and draw some lines. We're going to have one line for each one of these. I highly recommend using different colors. I think I'm going to stick with yellow. We'll go extra thick so we can see it. So for the mesquite tree, we're going to go with yellow. So 042. Well, here's 0, right? 0, 1, 2. 42 is less than 50. This has got to be 25. So that's, oh, I'm sorry. Yeah, 25. I don't know, 42 somewhere in there. And then for 1, it's 60. So about there. For 2, it's 78. So this is 75, so a little bit more than 75. For 3, it's 96, which is almost 100. For 4, it's 114. See, maybe 125, so somewhere there. For 5, it's 132. For 6, it is 150. Oh, that one's nice. We got that one exact. And for 7, it's 168. So 50, that would be 175. So somewhere around there. Yeah, with this kind of scaling, it's hard to be exact. So we're going to be approximate. I'm going to write these in, though. It'd be helpful to know that this is 25. This is 75. I highly recommend you write these in as well. 125, 175, and 225. Okay, so let's draw our yellow line. I'm only gonna have one arrow because this can't go negative. So we're gonna go that way and it should keep on growing. So that's our mesquite tree. Let's go to green for our willow tree. All right, 0 is 88 inches. 88, it's gonna be somewhere between 75 and 100. And then 1 year is 96, so almost 100. 2 years is 104, so a little bit over 100. 3 years is 112, less than 125. 4 years is 120. 120. I think I made that one a little too high. 5 is 130. Oh, 128. That's a little bit above 25. 6 years is 150. Oh, I'm doing the mesquite, aren't I? Whoops, not that one. Undo that one. 6 is 136. So that's going to be less than 150. And 7 is 144, still less than 150. So I don't think I did as good a job on that one at keeping it linear. I'm going to erase this guy and slide him a little lower. That's not right. He should be somewhere in there. Okay, let's draw our line. It's not great. It's not bad. All right, so there's our line. Going through our points, we knew it was going to be linear. So if it's not perfectly linear, it's probably our poor graphing and not the equation's fault. So they said graph the equations. So we graphed using a table. We could have graphed using the slope and the y-intercept, but not on this grid. There wasn't enough information to start at 42 and go up 18 and over 1 and up 18 and over 1 and up 18 and over 1. We should have been able to do that, but this graph is just too vague. So plotting the points was better to graph these lines. What we are looking for in a system of linear, I'm going to make it red because this is the most important thing. If you didn't listen to anything else in this lesson, listen to this. What we are looking for is where the two lines cross. This is the solution to our system of linear equations. This is telling us where the input and the output are the same for both of our equations, right? And so for us, it looks like it's happening after 4 years, but before 5 years. Let's check the table. So at 4 years, the mesquite tree is shorter, and at 5 years, the mesquite tree is taller. So somewhere between 4 years and 5 years, they were exactly the same height, right? So there should be some time in here. Let's stick with that. On the number line here, or on our graph, that has exactly the same height. And that is the solution to this system of linear equations. I don't know exactly what it is. I know it's approximately maybe 4.8. And the height of both trees, when they were the same height, is going to be around, I don't know, 130-ish. Okay? System of linear equations. Two equations whose variables are the same, mean the same thing, but have different slopes, different y-intercepts. To find the solution of the system, we're looking for when do both of those equations have the same x and y value, or in this case, the same t and h value. All right, thank you for listening.